Hi and welcome. So I picked up a couple more items this week from eBay, and you can never tell what you're going to get on eBay. You know, you only can see from the pictures and the description. You got to trust. So picked up a few items. Like I got these wheels here, these Norton wheels. These are 4-inch wheels, 1/2-inch arbor. They're for the grinder that goes on my lathe. And Max, if you're out there watching, if these are the right size for you and the right grit for you, let me know and I'll send you a couple. And of course, when you get them, they don't show you that a couple of them have chips in them. Mostly they're okay, but you can dress a lot of that off. I also picked up this boring bar because I'm trying to get a few more boring bars in different sizes that have a lot more clearance. So these use these diamond inserts, these diamond shaped inserts, DMT or DCMT. And the beauty is they have more clearance. They're not as strong as some of the other styles, but they've got more clearance. And this is a carbide boring bar. However, it looked a ton bigger in the picture. And then I thought, you know, why is that it looks so much bigger? And the one that I'm supposed to have gotten was supposed to be a C12. This is a C10. So this is 10 millimeter. The one I was supposed to get was 12 millimeter, or roughly 1/2 inch, a little bit under. This one's 0.390. So they sent me the wrong boring bar. Next up, I ordered this guy from Bulgaria. I always wanted one of these kind of levels. It's one of those things. I've got a thing for tools. And this is a West German made one. You can see there. It's very interesting design. But it looked much better in the pictures. They didn't have any close-ups. And this one's got some corrosion going around here. So I'm going to measure this guy. It's number 490049 with some random 3 over here. That's kind of interesting. But this kind of square can be really handy. I've seen other guys use them, and it has the vials in both directions so that you can do simultaneous 2-direction leveling, which is pretty handy. So I thought this would be nice. It was about $200, which would be a good deal if it was in great shape. I'm not quite as pleased considering what shape it is in, but I'll take a look at it. We may have to take this over to the service grinder and fix it. By the way, this whole episode is about eBay purchases gone wrong. So hold on one more. A while back, I was looking for an Edwards vacuum pump and found this deal on this one, but sometimes a deal is not a deal. This one, the motor's seized on it, and the box with the electronics in did not survive shipping. This thing came in very bad shape. So I got credited, and that's fine, and they just didn't want it shipped back. So maybe at some point I'll take it apart and see if I can fix it, but I think it's going to kind of be challenging because this thing's in a bad way. Plus, with vacuum pumps that might have been used for semiconductor manufacturing or something like that, like this could have been, they didn't know where it came from. I was reading on Edwards' website that you've got to be very careful because they may have been sucking very dangerous chemicals into this thing, and they could have dissolved into the oil inside, and that could be a huge problem. So it might not be worth digging into just from a safety stake. So this one's probably a complete loss. And the last item was this guy, which was whole on eBay when I looked at it, and it did not survive shipping either. The box had exploded on shipping. The electronics box was completely destroyed. They showed this in the ad, so the belt was cut most of the way through, and I used some Loctite with the rubber reinforced Loctite, the Supermax Black. You got to keep refrigerated, and so that's all good. But there were some dings in this, and the plate, the mounting plate here, was in really poor shape. This piece had banged into this and taken some chunks out of it, so I reground this. I won't be able to show you the damage because I've already fixed it. So I ground and chamfered this guy, but as you can see, there's already lots of scratches in the bottom, and that's because this is not hardened steel. So it scratches very easily, unfortunately. It would have been better if it had been hardened or even case hardened. If I'd known that, I might have tried some cherry red on it first and then ground it after, although cherry red does not get a very deep layer of hardened material. So anyways, but I am going to try and salvage this guy, and I'm going to try and make a new a new box for this. So I've got an idea here, and I'm just going to pursue it, because after I rewired it, some of these wires were off, and I figured out what went where. It does turn on. This uses 5C collets, and the bearings seem fine. Oh, I also had to take both pieces off here and clean the guts out. They were kind of dirty, a lot of grinding dust in there, but the bearings still seem good. And actually, they had the front and rear pieces, or the bearings spacer inside that puts preload on the bearings was not incorrectly. Someone had this apart and didn't get together right. There was a ton of slop in this 5C bore here, and now it's nice and tight because I redid it. Put the spacer on the right side. Now it's nice and tight, and that's a big plus. Again, going back to this material here, the fact that it's soft steel, that they just looked like they used cold rolled or hot rolled or something like that, and then so like I said, I ground it flat again and put the pins back in and everything. But the problem with it is, because it's so soft, if you turn up a burr, say down here, that means it's going to tilt back ever so slightly. And so your work that you're trying to, like your pin that you're trying to grind down, is not going to be parallel to the magnetic chuck, which is not good. You'll have a slight taper in it, which you don't necessarily want. So I'm going to have to be very careful when I use this, or I'm going to have to get a piece of hardenable steel, harden it, and then regrind it for the base on this guy. I've got this piece of Delrin right here that I bought. And again, this was something I tried to buy it in black, and then they sent me an email saying, well, we don't have it in black, we only have it in white. So here's what I got. So we're going to try and make a new box for this guy out of Delrin. This material looks a lot like Bakelite, which was really popular in the 60s. Anyone ever has had a Simpsons multimeter, kind of famous? They were Bakelite cases. And Bakelite is interesting stuff, but it's kind of brittle and it shatters pretty easily, which this did on shipping. Next up, we're just going to saw this piece off here. I think I would have used a blade with a lot deeper gullets in it if I was going to do much of this, but I'm just cutting the one piece, so I'm not changing blades. Alrighty, so we have this piece here. Boy, the finish is pretty darn decent considering. I mean, that's just bandsawed. One of the deburring tools that came in my Shaviv set is this ceramic one, and it's supposedly good for plastics. And yeah, it kind of looks like it works pretty well. I've still got to reduce this to final dimensions, so there's no reason to go overboard on it, but yeah, it worked really well. So there's the Sarah burr. It's got a ceramic tip on it if anyone's curious, by Shaviv. And you can already tell I wish I had black, because this shows dirt like there's no tomorrow, and on the grinder, boy, this is going to get ugly fast, but it'll be functional. To cut this material, I'm going to use this face mill, which has positive rate cutters designed for aluminum, so hopefully they'll be sharp and do a nice job. So none of the dimensions on this are particularly critical. I bet you if I'm within 1/10 of an inch, it's going to be more than fine. But this is plastic, so with the cutter rotating in this direction, the cutter is going to push the plastic into itself here, but on this reverse side, it's going to want to tear out. So to get a good finish, what I should do is I should make a pass this direction about halfway, going this way, and another half going this way, and that way all these edges will be preserved except maybe this exiting one. That's my theory. Whether it actually works or not remains to be seen. All right. Oh, and that's what happens if you don't clamp the vise adequately. Looks like we're cutting another piece. That was an expensive lesson. That's what being less than careful will get you. That was a 3 horsepower motor that it knocked to a complete stop. Yeah, you can't feel anything. That is nice. I'm going to take this guy, I'm going to remove the fuzz on this edge here, which is kind of interesting. And we're going to flip it 180, and we'll just continue squaring this guy up. I don't know if you can see the surface finish, but it's like mirror or glass smooth. There is just nothing. This is a great, those are a great set of inserts for facing this material. Next up, we just got to hollow this out. I've got a 3/8 inch aluminum cutting bit here. All right, so just for curiosity's sake, let's see how it does when you try full length of cutter here, nibbling off. Now we're hollowing out the corners, leaving a space for the screws to attach. But the chip buildup, I'm doing a full length of cut here, 1.75 inches, which is kind of extensive, so I'm clearing the chips out. My vacuum cleaner can't deal with chips this large. And that should complete the inside of this guy. If it looks like my hands are close, they're actually not at all close. This is a fairly big box, and I'm using the pencil anytime my hand needs to get anywhere near the cutter. I'm crazy, but not that crazy. So we got it hollowed out. We decked this. I need to come back and take a little more material off both of these sides here to fit the PC board, which for whatever reason they didn't center it. I don't know, it makes no sense. I mean, it gave a little bit more room for wires on this side, but anyways, we got a good fit now. So we can drill and tap some screw holes in here to mount this. There's some more screw holes and an entrance hole for the power on this side, and there's one mounting hole that goes from the bottom, which we will do after this. Here's the old piece remaining. See the brass inserts, threaded inserts there? But I went straight in with threads. I suppose if I have a problem at a later date, I could always press some threaded inserts in or something like that, but I don't think it's going to be a problem. There's not a lot of force on it. All right, so next we've got to drill 2 through holes and a big hole for the cables to go through, and I've got to make sure to get the side right because I only had relief on one side here. And then there's another hole that goes down here that attaches to the base. I'll take you over so we can take a look. All right, so it became more apparent why they skewed the PC board to one side was to give some space for the wires here. And so this has to go this way only. So there's relief for the PC board cut in on that side. The wire entry point is over here, which has this very carefully drilled round-ish hole here with 2 screws spaced 1 inch apart. So I need to figure out how to get those guys lined up. That slides over here. And that part goes down. I might have to figure out how to squeeze these wires in here temporarily to try and get a location. This is going to be interesting. I know the width of those holes is 1 inch, so that helps a little bit, but the height is important because this thing sits flat over here, and there's a screw that holds it onto this piece as well. I assume, which maybe is incorrect, but I kind of assume that you don't want it centered to give maximum spacing away from that, so I think you want it skewed kind of like this. So to get this guy, we're going to use a threaded point, and we'll be able to put a mark on the bottom. To locate this screw hole, I'm going to use this 1032 center finder set here. So I'm going to take one of those inserts out and pop it on this guy right here. and thread it down till the point is just barely above the surface here. And hold that flush and just press down. I don't know if you can see that, but there's the hole right there. So I need a number 10 clearance hole right there, and that'll line that part up, and then I have to figure out how to get these holes lined up, which might be a bit of a trick. With a little bit sloppier approach, I've got these little insert guys that mostly fit in these screw holes, and I'm lining this up the best I can with this 1032. I may have to end up opening this hole up just a little bit. So we're going to drill these oversized. These guys are number 6s, so we'll give them some latitude, because unfortunately I can't get the positioning a lot more accurate than that. This thing's C-shaped, so I can't easily get a part in here to line this up, which would be nice. Then also it has to be down far enough, which presents a lot of challenges for this guy. Alright, so I put the 2 screws in, I drilled that. So I'm going to use that to find this other hole up here. And I'm just going to mark it out. It's a very carefully rounded hole, so it's going to be hard to get it, you know, so perfect. I'm just kidding, because it looks like it was drilled and filed, or I don't know. That's crazy. Or a couple of drill holes. So we're just going to find that spot and get close. So we match the poorly aligned holes and we're just going to attach this guy loosely to start. So it looks like everything lines up nice, so I can actually cinch these down, so I should pop that off. Just give those nuts a quick tighten. That's really solid, so that's great. So I'm reattach the wires, and I marked them out. So we've got ground over here. Hot, which is black typically. And neutral. And black and red for the DC motor. I made this a little deeper, so there should even be more clearance than there was before, which is a good thing, I think. Alright, so here's my case on. I left a little bit of gap because the dimensions were all very rough, so I didn't try and get it super tight. Oh, look at that. Discovered something else. I thought I was almost done, but discovered that the belt is rubbing on the bottom of the box. And unfortunately, the previous box had exploded so badly there wasn't enough left to tell if they actually had put a relief in it or not, which they must have. It was Bakelite, so they could shape it any way they want. So I'm guessing they put a relief in for the belt. So I'm going to do the same thing. I'm just going to remove some material off the edge here, and which means I got to take it all apart and reassemble. I'll bring you right back. Here's a better view of the belt relief. And the belt's taut, it clears. And that's all we needed. All right, so we got a relief in here. And if I tilt this guy up, you might be able to see a little bit. See the relief right here? It's got clearance for the belt now. I couldn't see how the original box was laid out, so I didn't know to duplicate that till the end here when I discovered that the belt was rubbing. I'm lucky I biased this box all the way off to this side, because the farther out, the deeper that relief would have had to been. Fortunately, this relief doesn't open up to the inside of the box, so that's a huge plus. Just start this guy up. Got a 5C collet in there right now. That's full speed. And there's low speed. So you've got really good range of control. And inside this motor controller, there's a max and min speed adjust that you can set. for your limits. And that's it. So after about 8 to 10 hours of work into this thing that I bought on eBay that was supposedly functional to get on the get-go, we got it working again. Got a nice box for it to be in, for the speed control to be in, electrocution resistant, or pretty much proof at 110 volts. So pretty good. And we fixed the belt, even though I knew that in the ad was bad. Reground this plate, like I said earlier, and I think what I need to do is make a better motor tension adjust, some sort of screw adjust that lets you set it rather precisely, because right now it's just friction of this one bolt, and one bolt is never a good way to do it, even though it's a 3/8 inch bolt. So we need to improve that. I'd also like to use hardened steel for the base, because this one scores really easily. But beyond that, it's a nice tool, and I look forward to using it. Hope you find it useful. Thanks for watching. Hope to see you next time.